The lesson is on finding the area of regular polygons. When we have a triangle and we know the height and the base, we can find the area with half BH. When we have a rectangle or a parallelogram, if we know the length and the width, here we call height and base, we multiply the two and we get the area. When we have a pentagon that is regular, we can find the area by starting to divide the polygon into 5 equal or congruent triangles. Drawing these lines form 5 congruent triangles. Since we know how to get the area of a triangle, if we get the area of one triangle, then multiply it by 5, we get the area of the whole pentagon. And we can find it because with a triangle, we find the height and the base, use the formula half BH, and then we multiply it by 5, we get the area of the polygon. So we assign the height and the base for the triangle. The formula we're using, the area of a triangle is half BH. In this case, we can find the formula for the polygon. So it's half BH, which is the area of this triangle, multiplied by the number of triangles, which is the n, that's the area of the polygon. The polygon has 5 sides. We add that, we call it the perimeter. The base is one of the sides. The base of the triangle is one of the sides of the polygon, and it has 5 sides, which is the n. So that's Bn. The perimeter of the polygon is the base of the triangle and the number of sides. A polygon has an apothem. An apothem is called h here, the height of the triangle. But if we don't consider the triangle, this line here, which is from the vertex down to the opposite side that makes perpendicular, it is called apothem. So with all these variables, the area of the regular polygon can be written as the half apothem times the perimeter, which is based from the area of the polygon using the area of the triangle formula. The apothem is the height, which is the h here. The perimeter is the Bn, which is the base times the number of sides. And considering the half there with the half here, the area of a polygon, the formula is half AP, apothem times the perimeter. Let's have an example. We have a regular pentagon and the apothem is given as 6 and the base is given as 8. The formula for the area of a polygon is half AP. We have the apothem, which is 6, but we don't have the perimeter. So the perimeter is computed as the side, the base, which is 8, multiplied by the number of sides, which is the 5. So we're getting an 8 times 5, that is 40. The perimeter is 40, the apothem is 6. We're ready to substitute, plug in the values for half AP. 6 is for the apothem, 40 is for the perimeter. 6 times 40 is 240, half of that is 120. So the answer to the area of the regular pentagon is 120 units squared. There is no unit given here, so we just write units squared for the unit of the area of the regular pentagon. Let's have another example. Again, we have a regular pentagon. Now in this case, we have an 8 that is given, and that is the radius of the pentagon. The 8 here is the radius of the pentagon. Radius is from the center going to the vertex of one of the vertices of the polygon. So 8 is the radius of the pentagon. And x here is given to be as this half of the whole side. The formula for the area of a polygon is half AP. We need the apothem. The apothem is not given. We need the perimeter. To solve for the perimeter, we need the whole side length times the 5 to get the perimeter. And we don't have all those values. We are only given the 8 here with the x. Now, we notice that there is a right triangle that is formed by the apothem. So if we are only given one side of the right triangle, we can use the trigonometric functions sine, cosine, or tangent. So we need the angle measure of this angle. So how do we do that? The whole circle has 360 degrees. There are 5 triangles, so we can do 360 divided by 5. We have a 72. Each of these angles measures 72 degrees, but we need only half of it, which is the mark theta here. So we divide the 72 by 2, we get a 36. This theta is 76. Now let's solve for x. X is the opposite of the theta. 8 is the hypotenuse, so we can use the opposite and the hypotenuse, which is the sine function. So because theta is 36, we can use the sine function to solve for x. So sine theta is equal to x, which is the opposite, over the hypotenuse, which is the 8. So cross multiplication, the 8 will multiply the sine theta so that we can get the value of x. So we have 8 times sine 36 because theta is 36, the value of which is 4.70. Now 4.70 is just this x. We need the other side, which is the same value as x. So we do 4.7 plus 4.7, which is 9.4. So this is 9.4. So to solve for the perimeter now is the 9.4 multiplied by the 5 sides, that is 47. The perimeter is 47. We get the P. Now we need to solve for A. This is A, the apothem. And with the right triangle, the A here is the adjacent side to the given or to the known angle, which is theta. So since we have an adjacent side and hypotenuse, we can use cosine, adjacent over hypotenuse. While we already know the x, which you can use for A, so you have tangent, which is opposite over adjacent, it is always good to use the given value, which is 8, rather than the x, which you just found a while ago. So let's use the hypotenuse and the adjacent to solve for the apothem, and that is cosine. So solve for A, we have cosine theta is equal to adjacent over hypotenuse, which is A, 8. Again, with cross multiplication, the 8 will multiply cosine theta, and that's solving for A. And that will give us a 6.47 for A. So we now have a value for A, which is 6.47. Now we're ready to solve for the area of the regular pentagon, because we already have the apothem, which is 6.47, and the perimeter, which is 47. So plugging in the values, you'll be getting the value of 152.045 units squared. This is the area of the regular pentagon. We say unit squared again because there are no units given for the values.